Okay, this is Steven Stadler and Jacob Mustaine, and we're going to show you how to build an op-amp audio amplifier. And what we're going to start off with here is showing you how to power your op-amp. So we got a 9-volt source here, basically a 9-volt battery, and this is in series with two 1K resistors. And what that allows us to do is have an equal drop to both sides of our circuit here to power this op-amp. So the drop up on the top rail here is going to be a positive 4.5 volts, and the bottom rail here is going to get a negative 4.5 volts. Okay, so on our breadboard here, this green is going to be our positive end of our 9-volt source, the red is going to be our negative, and we have our resistor here, our 1K. This runs for this positive side, and this capacitor is here. This negative side here runs down. Here's our 1K there to this 1K. Here's this capacitor. This wire here, if we can get in clear, yeah. This is our common ground, and then these two wires here, what this allows us to do is jump this positive voltage over to this rail, and our negative voltage here over to this rail.
Alright, right here is our schematic for our op-amp amplifier once we already have our voltages that power the two op-amps. Now for our headphones we have a left input and a right input. These will be the same setup for both. Right here is a variable resistor that goes up to 50K, and we want a 10 times jump in our input. So we have a 5 kilo ohm resistor, and then our max for our resistance for our variable resistor is a 50K, which will also go down to 0. The amplifier works on V out equals RF over RI, so when it's 50, we'll have a 10 times increase in our input, but when it's 0, our output will go to 0 and turn off our amplifier. Here's our schematic for our op-amp that we have. This is our input, which will take that 4.5 volts that we explained earlier, and this will be the negative 4.5 volts that we explained. Now we'll use both of these working together, and we'll use the same changing resistor for both of these so that we won't have any differences in sound quality. Start. Alright, this is our LM358N op-amp. This was the setup that we talked about earlier. We've got our V negative coming into it, our VCC positive coming from this side rail over here. This is our, I don't know if you can see it very well, this is our non-inverting input B that's going to ground, and then our non-inverting input A that is also going to ground, and then we have our inputs from our headphone jack that we plugged into an iPod, and those are going right here and here, and they're connected with this resistor right here going to each one for our left and right audio. And then we have it jumped across using this resistor, and these are both our 5 kilo ohm resistors, and then this is the 50 that will give us the 10 jump in our voltage. And we'll plug everything up. We've got the 9-volt source going to our 4.5 volt difference to our ground, and then this is our speaker that we have it hooked up to. And this is how we have it started up, and then we'll turn it up. And we'll turn it down now. And that's how we got it to work. We just used this same resistor, and we used the difference through both sides to do the left and right at the same time and not change the audio at all.
Okay, so just to kind of rerun over things again, we powered our op amp. You've got the 9-volt battery source. You got your positive 4.5 drop on the top rail, negative 4.5 on the bottom rail. Again, that powers your op amp. Now we'll come over here and then amplifying the input. Remember, you got your left and your right inputs. You got your two input amplifiers here. Again, remember your V out, your voltage out, is equal to RF over RI times VI. And then over here again, what you get out, this V out is going to be supplied to your left output and your right output. And that is how you can build your own audio amplifier at your house.